Okay, here we go, guys. 4G. So we're on practice test 1. And we are looking at... Guys, thank you. So, practice test 1, we're doing 4G. Ready for that one? So, let's get our logarithms back front and center. What are you going to do with a problem like this? Loop-de-loo it. Absolutely, we're going to loop-de-loo it. What's my base? E. There's a E right there. So e to the negative first equals x. What is e to the negative first? 1 over e. That's exactly right. Done. Takes just a second to do. You know what you're doing. All right, how about this one? What are you going to do with this? Remember, this is no calculator now. Or no big calculator. No, we can't divide. There's nothing to divide. What'd you say?
What do we set the bases to say?
She says change them into 3s. Make the bases the same. So what's 27? 3 to the third. What's 9? And as soon as the 3's, the bases are the same, what are we allowed to do?
Cancel out.
Get rid of them and just solve the exponent. So 3x equals 2. So x equals 2/3. Okay? What about I? What are we going to do with problem I? Loop-de-loo. When in doubt, loop-de-loo. If you have one logarithm in your problem, loop-de-loo. So what does this say? X squared equals 9. So x equals 3. Number 5, still no calculator. Write as a single logarithm. All right, so let's be sure we understand the end goal here. You are going to write log parentheses. 1 log, 1 parentheses, and now you're going to fill the parentheses. All right, so what's going to go in there? First of all, would you agree it's going to be a division in there? So what's going to be on top? N to the 4th. Remember, a number out in front is an exponent in logarithm land. And then what goes in the bottom? Just n. That's all there is. Just n. There it is. Done. 6 is the exact opposite. It's already 1. And you're going to break it down so it's a log of something, and the log is something. Have an x and y. What's going to go in between them? A minus, because that's a division. And is that it then? Am I done? No. I'm going to do what with that 3? Put it out in front. And same with the 2. And that's it. Okay? Now we need our calculators out. Okay, here we go. What do you think about problem A, 7A? So what, if you remember, we did a whole page, or a whole bunch of this kind of problem. If you remember, that right there is going to be log 19 divided by log 7. Remember top number, bottom number? And you can type that in then. Now I'm going to show you something different in case you forgot that. But boy, if you remember that, you are all set. Nearest thousand would be how many decimal places? 1,000? 3. 10,000 is 4. Okay, so if you remember that, you're done with this problem. Now, what if you don't remember that? It's called a change of base, and it's wonderful that you remember it. But what if you didn't? What could you do with this problem? You could loop through it. Now, the problem is, it's not like that other one we did. This is not a 49. If that were a 49, life would be good. Well, what do? Take the logarithm of both sides. Whenever my variable is an exponent, I take the logarithm of both sides. And then this guy comes out in front. And look what's going to happen, you guys. What am I going to do? Aren't I going to divide by log 7? And aren't I going to have exactly what Mackenzie said from the beginning? So you can do it either way, it doesn't matter. You can loop-de-loo it, log it, and pull the exponent off and divide. Either way, you're going to get that answer. Okay? What about this? Divide by 5, always if there's an extra number. An extra number. Jarius, back when we had this problem, there is no extra number in there. If there had been something out here in front, I would divide by it, but there isn't. So I divide by the extra number. So a to the x equals 12/5. Where's your variable? Where's x? And when it's up there, what do we have to do? The only way to solve it when it's up there is to use logarithms. So I'm going to take the logarithm of both sides. And why is that so cool? Because now that x isn't an exponent anymore. Now that x is out here in front. Right? And then I can get my answer. I'm trying to get what x is, so when I just divide by log 8. Go to my calculator and type it in. Hopefully we all get the same answer. I got 0.421. Nod. Next, looks very similar. How are we going to start letter C? We're going to divide by -2. So we have e to the 3.8x equals 6. Is that all right with everyone? Where's my variable? And when it's on top, I have to use logarithms. If there's no common base, I need logarithms. Since the problem has an e in it, instead of log logarithms, I will ln. Kids, it really isn't going to impact your answer. It's just going to make your life easier. You can do it either way. But if I ln, what super cool thing happens? Gone. So 3.8x equals ln 6. And the answer will be ln 6 divided by 3.8. 0.472. Does that look all right to everybody? Okay, let's see what's on the next page. Oh, some word problems. All right, so you've got two formulas. I'm gonna give those to you, so I'll write them down up here at the top. But this is all you're gonna have on test day. I'm not telling you which one to use. I'm not telling you how to use them. I'm just gonna write it on the paper, just like this. So let's read number A and figure out, read it carefully, word, every word counts, and tell me which one we want, formula 1 or 2.
2.
I thought the exponent on the top is supposed to be RT. Is it N on the other one?
No, it's NT. Yeah. All right, so which one? 1 or 2? 2. How do I know? Compounded daily. The only time I'm going to use this formula for a money problem is if it says compounded continuously. This is continuous. All right, so now I'm going to stick stuff in. All right, this is my formula. Where does the 6543 go?
Here.
That's what I'm starting with. So 6543 right here. All right, where does the 10,000 go? The interest, be careful, what am I gonna put into the problem? 0.01875? 0.01875? What's my N? 365? Because that's how many days there are in a year. And my question is, how long will it take? So notice, where's my variable? Up there again, which means I'm going to eventually need logarithms, but not yet. What do I have to do first? What has to be step 1? Divide by 6543. That number cannot be there. So I'm going to have 10,000 divided by 6543. And I know some of you are completely, twitching because these numbers are awful. But every time you round off inside the problem, you're going to create round off error in your answer. Okay, a couple people have turned in this homework and every problem is wrong. Kind of close, but wrong, because we're rounding off too much. Don't round off, it's fine. It's fine, just like that. Now, once I've divided, now what has to happen next? I gotta get that down. And how do I get that down? What do I have to do? I'm gonna log both sides. And again, I am not worried about this. Yes, it's a lot of writing for me, but that's okay. Why did I log it? So that that would come out in front. So we divided by 6543 first, and then took the logarithm of both sides, and pulled the whole exponent out to the front. Okay, now let's not get bogged down. Let's talk about what needs to be done. if I want to know what t is, I'm solving for that. What do I have to do? I gotta divide by 365. Would you agree with that? So I'm just gonna do it right here. It's divide by 365. Okay, now that's gone. What else do I have to do? Look, what else do I have to do? I gotta get rid of this, don't I? So I'm gonna now divide, first I'm gonna divide by the 365, then I'm gonna divide by this big ugly mess. Come on, you guys are smart. You can follow this. We're just talking about what we need to do to get t by itself. So we need to divide by the 365, and then we need to turn around and divide by that logarithm. So that's how I'm going to type it in on my calculator. Log 10,000 divided by 6543, close parentheses, divided by 365. And then divided by log 1 plus 0.01875 divided by 365. Hopefully, you got 22.624 years. So, type this in. Divided by 365, and then divided by this mess right here. And you should get that right there. Anybody else get 22? Make sure I typed it in right. Okay. B, which formula for B? Number 1 or number 2? 2 again because it's compounded monthly. So I'm using that same formula. What do I do with 125? P. Interest rate is 0.03125. What's n this time? 12, because it's monthly. How long am I leaving it in there for? 50 years? Are we going to need logarithms this time? No. We're just going to type it in. I like to do this first. Just make that a 600. You don't have to, but I like to do that. Makes it easier for me. And then I just type it in. I got 595.13. What about you? You are not going to use logarithms in every problem, you guys. When do we need them? When x is up here, right? That's when you need it. If it's not, if x isn't up there, then don't use logarithms. All right, last problem on this practice test. Need a formula. First one. How do I know it's the first one? It's not about money. And if it's not about money, it's automatically going to be that one. All right, here we go. Where does the 13, this is my formula. Where does the 1300 go? P. Where does the 3100 go? Growth constant is 0.101. And I'm looking for T. Would you agree? All right? Okay. So now we're going to solve it. Are we going to need logarithms? Yeah, but not yet. What has to happen first? Divide. Now, if you want to, you can make this 31/13. See how the hundreds are going to cancel? If that confuses you, don't do it. Leave it 3,100 over 1,300. But certainly that's a reasonable canceling. Now what? ln both sides. Those are going to cancel. So ln either 3,100 over 1,300 or 31 over 13 equals 0.101 t. Remember, you're solving for t, so all you need to do is what? Divide. I got 8.604. Let me just say years. Could be days, could be hours, I have no idea. It's a time. Mm-hmm. Okay? Now I'm going to break from tradition here because of the timing of so much stuff and another day off for you guys, another missed class. Instead of having another quiz, we're going to do last year's quiz together. It's over there. Last part of your chapter. And we'll come back to your practice test, but we need this review. Now, when I gave this last year, for some reason, I don't know why, we only had to do 6 of them. Everybody get one? Okay. We're going to do them all just for good practice here. All right, so here we go. You should right now be able to do every single one of these problems. So, take a second, do number 1. Take a stab at it. Pretend it's a quiz. You got to do it. Chloe's already got it done. Chloe, what did you do for number 1?
I looped it, so I ended up with 4 to the x equals 16, and 4 to the second would be 16.
So x is 2. Is that all right with everybody? When you see one logarithm, please think about loop-de-looing, okay, in an equation. All right, number 2, take a second and see if you can plot out a strategy. Think about what are you going to do Raise your hand if you have a plan. Maybe you don't know how to do it, but you have a plan. One person in this room has a plan. Guys, please don't depress me. Jarius, what's your plan?
I am going to make them both 2. Well, I'm going to make the first one 2.
Yes.
And then,
Because, wait, Jarvis, you're right on target. We know that 4 is 2 squared.
yeah,
So you're gonna change your 4 into 2 squared,
yes.
and this one's already 2. And then what are you gonna do, Jarius?
Then, I already got my bases, so I'm just gonna cross out the big 2's, and then it's gonna be 2 plus 3. Oh, dang it.
That's exactly what it looks like, it's a distribute.
Okay, so is it 2 times 3 x
6x
minus a equals x
minus 16
Yeah, and then
equals x plus 7.
yeah.
So 5x equals 23. I got 23/5. Anybody working ahead and get that?
Yes.
Okay, let's all participate, not just sit there. All right, number 3, take a second, get a plan. Okay, Talia, I see you writing. What's your plan here, Talia?
I was gonna change it to
Okay, so you're gonna write 1 logarithm, and she says it's gonna be a division problem. Is she right? Completely and totally. All right, and then what did you put inside your parentheses?
x cubed and y squared.
Beautiful, 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 beautiful. Okay, all 3 of these were on the practice test, so that's why we're practicing this. You have to know how to do all of these on test day. All right, number 4. Take a minute, get a plan. This one, we can have several plans. Not everybody's plan has to be the same. So we'll go with whoever volunteers. Who has what you think is a good plan? Okay, Dave?
I put the X's and Y's together.
Alright, so she let that go for a second. So 4 and 7, nothing really to do with those. And then what did you do with your X's?
I moved the bottom X up and got X squared.
X squared, they cancel, folks, right? 3 over 1, they cancel. Alright, and then
I moved the negative 3 up and got y to the 4th.
y to the 4th, perfect. Now, she isn't done. Are you with her so far? You might not have done it this way, and that's okay, but she's right. And then she still has to do what now?
Distribute.
Square everything.
Yeah.
So that includes the 4 and the 7. X to the 4, y to the 8. Remember, we never square exponents, we multiply them. We multiply them. Speaking of negative exponents, what are you gonna do with this guy? It's gonna be 1 over to start with, right? It's gonna be 1 over 9. Because of the negative, we always take care of the negative first. And then what does a 1/2 mean? Square root. Square root of 1 is 1. Square root of 9 is 3. Since it's in the first power, that's it. 1/3. Ay, 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 what is happening here? Divide by 2. That is an extra number, it can't be there, we gotta get rid of it. So divide by 2. Oh. Now I have a plan? What's 9? 3 squared? This is just like Jarius's problem. Now, so 3 to the 5x plus 1 equals 3 squared? So 5x plus 1 equals 2. I got 1/5. Now, how's come my variable was up here in the exponent, but I didn't use logarithms? Normally, that's what I'm always telling you, use logarithms. Why didn't I need to? Because I could get a common base. Okay, so what I hope you're thinking about is, am I getting ready for a test? Do I feel good about these things? All right, number 7. Take a minute and get a plan. Now, can I cancel all the logs out right now? No, 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 no. When can I cancel the logs? When there's 1 on each side. So as soon as you make your problem say log equals log, then you can. So how are we gonna make that happen? The ones on the left side have to go together. I can't have 2 logarithms, folks. Can't do it. So I gotta put them together. How am I gonna put them together? What's gonna go inside that parentheses? 2x. Why is it 2 times x? Because the logarithms are being added. Now, men and women, can I cancel my logs?
Yes.
Yes. So 2x equals 7 and x equals 7/2. Okay. That caught a bunch of you off guard. Put a little star there. Cannot drop logarithms until there is just 1 on each side. Log equals log. Now, this is an expansion. Okay? This is an expansion. So this is going to become log base 7x, log base 7y. I'm pulling it apart. Okay? Now what do I do? What else goes in there? That's going to be a subtraction, right?
2 goes in front.
The 2 is going to come out in front of just the x one. And I'm done. Wait, have you ever early dismissal 2?
Yeah,
Did I know that?
I told you.
Yeah, okay, I forgot already. You're 3 o'clock too. He's 3 o'clock, you're 3 o'clock, you're 3:08. Okay, that's the answer. All right, number 9. Anybody who messes up number 9 needs a swift kick in the pants. Because in the problem, what is touching? Ln and E. And whenever they are touching each other, what happens? They cancel. So what is the answer to problem 9? 3x. 3x.
Would it be x equals 3?
No, 3x. Notice, Jarius, there's no equals in that problem,
Okay.
right? Yep, so don't put 1 in. Now 10 does have an equals, so I will be looking for x equals. What am I gonna do with number 10? 13 to the negative first equals x. What does 13 to the negative first mean? 1 over 13. So x equals 1 over 13 is the answer to problem 10. Okay? All right. Put that aside, and then let's get our practice test back out. And you will start practice test number 2. All right, everybody ready? Problem number 1, practice test 2. Is this growth or decay? Decay. What is the percent growth or decay? 39%, right? It says, what is the percent? 39%. How did we get 39? Where did that number come from? 100 minus 61. What is the initial value? 0.82. Write the equation of the exponential function containing these two forms. What is my answer going to look like? Y equals A times B to the X. So when you finally get an answer to this, there's the answer blank. You're going to put an equation that looks like that in the answer blank. All right? Okay. Well, what do I know right off the bat? A is 1/2. So Y equals 1/2 B to the X. Now I'll plug in, and don't freak out, be calm. 81/2 equals 1/2 B to the 4th. Now this is an easy one. Can't I just times by 2 and get rid of those fractions? So if I times by 2, I get 81 equals B to the 4th. Now what? 4th root. And this is where some of you have this memorized and some of you don't. What does it mean to be a 4th root? It means if you times the same number 4 times, you get 81. Okay? So if you don't know that that's 3, you can work it out on your baby calculator. 2 times 2 times 2 times 2 is not 81. 3 times 3 times 3 times 3 is 81. So B is 3. Do not write that in the answer blank. In the answer blank goes Y equals 1/2 times 3 to the X. A is 1/2, B is 3. Okay, my friends? All right. Now we've got a whole boatload of simplifies. So here we go. Test looks just like this. All right, so here we go. 81 to the negative 3/4. What are you going to do first? 1 over 81. Always, when you're simplifying these things, guys, take care of that negative first. And then you see an exponent that's a fraction. So that means you're going to have a radical. And it's going to be a 4th root cubed. Well, luckily we just did the 4th root of 81, so we don't need to figure that out again. The 4th root of 81 is 3. But I need to cube it 1 over 27. negative third? Do I need to write it down? Can you do 2 to the negative third? 1/8? Because isn't it 1 over 2 cubed? 1/8? 1 over 8? What about C? Because of the negative, first we'll flip it. Right, my friends? Numerator is 9 squared, 81. 16 squared, you might not know that one by heart. 16 times 16 on the calculator would give you 256. D.
Cancel.
D.
Cancel is
Negative 6?
X.
Negative 6. Is there an X in the problem? Negative 6. Why is it negative 6?
Because ln and e.
L and E cancel. What are you gonna do with E? I told you a bit ago that if you have one logarithm in your problem, you should think about loop-de-looing. And I'd love to think about loop-de-looing, but I'm missing something here. What am I missing if I want to loop-de-loo? I'm missing something on the other side. So I'm going to stick an X in this time. And then when I loop-de-loo, it looks like my answer is going to be 2. And if you put X equal 2, I wouldn't get mad at you. 2 is the actual answer. There's no X in the problem. All right, how about F? We did one like this a moment ago. And Maeve's, it was her problem, it was her idea. Maeve said, let's clean up the inside. Right? I like that idea. You do not have to do that, but it's my favorite thing to do. What happens to the X's? And be careful, what's gonna happen here? They're both gonna switch. So the 4 is going on top and the 3 is going on the bottom. And then what happens? They cancel and leave me with 1 on the top. The Y's aren't moving, but they're canceling and leaving me with 1 of those on the top too. Also. Now I'll square everything, so I have 9 and 16, and X squared and Y squared. You okay? G? 12. That's another one of those crazy canceling problems, guys. The answer to G is 12. H is another problem with a logarithm that I'd love to loop-de-loo. Even if I put an equals X over here, I'm still missing something. What am I missing? My base 10. So 10 to the X is 1/10. Now you gotta be smart. Negative 1. Why is it negative 1? Because it's 1 over. Right? It's gotta be negative 1. The answer is negative 1. How about I? Flip it and make it 4/3 squared. So the answer is 16/9. J? 6. All right, number 4, a whole bunch of equations to solve. without your calculator. Alright, so here we go. What is your thought when you look at problem A? Loop-de-loop. How many logarithms are in the problem? One? Please, when there's one logarithm, think about loop-de-looping. Even if you don't end up doing it, think about it at least. So what does this one say? 4 to the third equals x plus 1. 64 equals x plus 1, and x equals 63. We okay with that? All right, B. I heard a divide by 4.
No. Yes.
Yeah, that's an extra number out there, so we're gonna divide by 4. So 3 to the x equals 9. So x is 2. Very scary looking problem, ended up being super simple. All right, next. Divide by 3, Jordan says. Is she right? So log x equals 2. 10 to the second equals x, so x equals 100. All right, talk about scary. 27 1/3 to the 2x equals 243. Step 1, divide by 27. So 1/3 to the 2x equals, you'll have a baby calculator. I think that's 9. Right, now this one's tricky. We need a common base, don't we? What base do you want to use? 3? 3's a good base. Doesn't matter, I'm using 3. We can use 1/3 also, doesn't matter. 3, I'm using 3. If 3 is my base, then 1/3 is 3 to the negative first, right? If 3 is my base, then 9 is 3 squared. So negative 2x equals 2. It looks like my answer is negative 1. You could have, I heard Jordan up there saying I would use 1/3. You could have used that, but then this would have been 1/3